So you guys know Roman numerals. Extremely fun. We all use them as kids. But we want to extend it. And that's why people invented the line to represent multiplying by 1,000. 1,000, 5,000, 10,000, 50,000, 100,000, 500,000, 1,000,000. Then we can use it again for billion, trillion, quadrillion. But then there's too much line. But now there's too much line, so we place down a number. You stupid! That's a fraction! Yeah, it's a fraction. Who invited you? And that's how I, the great 2048, will help this solution. You'll be just removing everybody, right? Okay, so we're actually going to shrink the number so that nobody suspects it's a fraction. And now we have this. So with that, we can just put a... Actually, I haven't thought of this. A micrillion, thousand, and unmicrillion? Then we got... yeah... Then now there's too much line. And we can see that. So now we have this. Let me just remove this. This is denoted as 10. It's kind of approximately 10 tetrated. No, wrong. It's 10 tetrated. No, wait. It's 10 to the 3 times 10 tetrated to 1,000,000. Holy moly. So now this is a big number. I don't really think it's like 10 tetrated to 1,000,000, but I'll still accept it. So then we can just repeat the process again and again until we get to a wall. But we're going to have two little numbers to even represent. So then we'll have to use a new notation. Let's just grab our number again, which is obviously bigger. And now we place it here, but we see that there's too much. So let's put a line with a cool little line called a telemark. Or a Teletubby. That's what I'm going to call it, a Teletubby now. As of now, it's called Teletubby. These Teletubbies denote how big the stack is. So we're going to have a stack of 4. And we can nest Teletubbies. Tinky Winky. But then we get to a barrier. We ran out of Teletubbies. So let's use the second Teletubby. So you know how math uses these telemarks to prevent rectangles from looking equal. Yes, I kind of copied their homework and did this. If we and don't convert this to decimal. If you try, you just get an error, and your mind might explode. But what I'm saying is that this number is greater than Graham's number. But then what if we have more Teletubbies? Well, let's just draw these squiggly lines. Did you know, like, there's like a million of Teletubbies, of Bella Bubbies, of Mellicubbies, of Biba Bubbies, of blah 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 blah. Now we won't use a million lines. Instead, we denote it. Ta-da! But there's no space. Well, let's just separate this giant cluster of Teletubbies. Now this is a million Teletubbies. A trillion. Quadrillion. A quintillion. We use the same notation again and again till we hit a wall. And guess what? Teletubbies. Yep, those things exist. And then we can nest that. But then we hit a new barrier. So then we had a circle. A big circle denoted with I. Now if you don't get how this works, whenever we just nest this, we just have to do this. But we're using Roman numerals, so we go with VI. And then we can nest that with itself. So then we actually do this. A Teletubby with a big circle and 1. We just keep on doing this till we get like enough Teletubbies on circles and stuff. Then we hit a wall. What do we do with the 1? Now this is where that 1 comes from. The big circle represents how many times we've done that. So we're going to have 1 with 2, 1 with 3. But actually, it's going to be 2 is going to be here. And the big Teletubby thing will be nested onto here. Here will be 1 Teletubby. Here will be 3 Teletubbies. One of those guys. We can get bigger and bigger and bigger and bigger and bigger and bigger. And then we can nest that number in itself. And then let's just repeat the process again until we hit a barrier. There's 4 times, but we don't know how to nest it. So now here's this new notation, the square. How it works is it denotes how many times we nested it. So then we could go to 2, 3, 4, repeat that process again. And then that Teletubby changes. The square Teletubby changes to 3. And yeah, you get the point. It's just filled to the brim with Teletubbies that it's literally La La Land. Don't tell me what next? A baby centipede? Are you kidding me? Goo goo gaga. Don't worry, I bombed the baby. Now we have this giant number that looks like it shouldn't exist, but it exists. So we add another square, and how it works is that it does the nesting of that square. And then we can nest that too. Yep, the nesting won't stop. But then we add a square above it. How this one works, it repeats the previous one. It's like number blocks. And then you may think it goes here. No, now it goes taller. And yeah, you get the point. Until there's too many blocks, so we denote it with a number. And that number can re-nest itself. But first, let me just make this big number. Yeah, and the situation is we can nest that. So let's just recreate the Teletubby thing. We get so big, we surpass Tree 3, Rayo's number, Pfefferminch, utter oblivion, and then infinity. It's not the normal infinity spinball. Instead, since it looks like a sideways 8, we're just gonna make a sideways 8.